Hello everyone. In this video, we are going to transform reciprocal function of the form f of x equals 1 over x minus h plus k, where the parent graph of this function that we have here is y equals 1 over x. So pretty much this h and k are parameters, where the h shifts the graph left or right, and the k shifts the graph up or down. Let's take this first example right here. So we're supposed to graph y equals 1 over x plus 4 minus 3. For reciprocal function, we will be able to come up with two asymptotes. Again, there's another video that talks about how to graph reciprocal function using Desmos. I will put the link of that video in the description box below. But we're gonna have both the horizontal asymptote and the vertical asymptote. Now let's start first with the vertical asymptote. To determine the vertical asymptote, we are supposed to set the denominator equal to 0. We can get the vertical asymptote. Now, in this example that we have here, we can set this equal to 0. So that would be x plus 4 equals 0. So minus 4 from both sides. So minus 4 and minus 4. So then we are left with x is equal to negative 4. And this is our vertical asymptote. So I'm just gonna label this as VA, stands for vertical asymptote. Now to get the horizontal asymptote, it is this portion right here. We set this equal to y, so then we can go ahead and say that the horizontal asymptote for this graph, which I will have an acronym of HA, horizontal asymptote, y is equal to negative 3. So in order that we can graph the this function that we have over here, first we are going to sketch the asymptote first. So we have x is equal to negative 4. So I'm going to create a broken line. Vertical asymptote means it's from top to bottom. So I will create this broken line on x is equal to 4. This is the vertical asymptote. Now we are going to draw the horizontal asymptote. Y is equal to negative 3. So it's gonna be down here. That's negative 3. So I'm going to create a broken line. And this is the horizontal asymptote. Now to draw the graph, we remember that the graph gets closer and closer to the asymptote, but will never touch it. So we can go ahead and sketch the graph this way. So this is the graph of y equals 1 over x plus 4 minus 3. Now let's determine the domain for this graph. So the domain for this graph would be, so if we talk about the domain of a graph, we are supposed to determine all the x values that are part of this function. So looking at the x values from left, again, domain would mean from left to right. So as you can see, this one is going towards infinity. This one is going towards infinity on the right. So if we were to trace this, that means all of the x's will have will be part of the domain, except for x is equal to negative 4, which is the asymptote. So the domain for this would be all real numbers. That's how we represent all real numbers, except that's gonna be except negative 4. Okay, so that's the domain. Now let's find the range. The range would start from bottom to top. So let's see, remember that this arrowhead tells us that it goes all the way to infinity. This one it goes all the way to infinity to the negative side. So if we start to trace this graph from the other end, from top and bottom, so that means all of real numbers will be included except for the asymptote, which is on negative 3. So then we can go ahead and say that the range is all real numbers except negative 3. Now I will give you a trick on how to determine the vertical asymptote that fast and the horizontal asymptote that fast. So without having to do all this work. So the vertical asymptote would just be the opposite of this. So as you can see, this is plus 4, so that means it's a minus 4. So this one right here, we are supposed to keep the sign. So pretty much this one right here, we're supposed to switch the sign. So switch the sign of that, and we keep the sign of this. So that means to switch and keep. Let's try another example right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. Let's first determine the asymptote for each of these. So let's start with the horizontal asymptote. So please remember that the horizontal asymptote is this part right here. That's the horizontal asymptote, which is, so I'm just gonna write the horizontal asymptote right here. So horizontal asymptote is, that's gonna be y is equal to positive 2. So that's the horizontal asymptote. The vertical asymptote, again, remember that we're supposed to keep the sign of that. So that's why it has the positive 2. The vertical asymptote, we set this equal to 0 and solve for x, or pretty much like if it doesn't have any partner, then that means x is equal to 0. So pretty much in this graph, we can draw the asymptote first. So the vertical asymptote is in x equals 0. So that's gonna be right here. So this is where the vertical asymptote is. And the horizontal asymptote is on positive 2. So positive 2 is gonna be right here. So this is our horizontal asymptote. Now the graph would be sitting on the upper right side right here and on the lower left side. Again, it's gonna go towards, it approaches the asymptote, but it's not gonna touch it. So the graph from here is gonna approach towards the asymptote, but will not touch it. Remember, asymptote is like a wall where the graph just gets closer and closer to it, but it will never touch it nor cross that asymptote. So we are going to determine the domain for this. So I will give you a trick on how to determine the domain. So the domain would always be all real numbers for a reciprocal function. So that's all real numbers, and the exception for that is the vertical asymptote. So in this case right here, that would be all real numbers except that's gonna be 0. So that means the line will never, or this graph will never cross 0. Now, I'll give you a trick on how to determine the range. So the range would always be all real numbers, and the exception for that would be the horizontal asymptote, which is 2. So that would be all real numbers except 2. Did you get the same answers as this? Good. Perfect. Now let's move on to the next one right here. Again, we are supposed to determine first. It doesn't matter which one you would want to determine first. Horizontal asymptote or vertical asymptote, it doesn't really matter. So, but let's have the vertical asymptote for this one, for this problem right here. Again, it doesn't matter which way you would want to do first. So the vertical asymptote would be this value at the bottom. Remember, I give you a trick. You are just going to switch the sign of this, because that is we're supposed to be using the zero product property, although you can equal this to 0 and solve for x, but the fastest way to do that would be, you can just go ahead and write this as x is equal to positive 3, because that's a negative. Switch it. Remember, switch and keep, so that would be a positive 3. So that's the vertical asymptote, and the horizontal asymptote for this is the value that is supposed to be right here. Now, this is where others would get it wrong most of the time. They're gonna think that there is an invisible 1 right here. That is not the case. That is a 0. So invisible 1 can only become invisible if it comes with a variable. So there's no variable here, so you cannot have an invisible 1 right here. But instead, that is pretty much like a plus 0 there. So that's the one that you have to remember. So if it's not there, just like how we did it over here, since it doesn't have any partner, then that means that's a 0. That's how we got the x equals 0. The same thing for this. Again, it is not invisible 1, because that's where most of the students would miss. They think that there is an invisible 1 right there. So the horizontal asymptote for this would be y is equal to, this value right here is 0. So then we can go ahead and graph the asymptote first. So the horizontal asymptote is y equals 0, so it's gonna be right here. This is the horizontal asymptote. And the vertical asymptote is on x equals positive 3, so it's gonna be right here. So I'm gonna draw a vertical asymptote here. That means that our graph again would be would approach or gets closer and closer to the asymptote, but it will never touch it. So it gets closer and closer to the asymptote, but will never touch it. The same thing for the other side. It gets closer and closer to the asymptote, but will never touch it. This arrowhead tells it that it goes all the way to infinity. So we are going to determine the domain and range for this. Again, I gave you a trick already on how to determine the domain. So the domain for this would be all real numbers except, again, the exception for the domain would be the vertical asymptote, which is 3. So all real numbers except 3. While the range for this would always be all real numbers except, that's gonna be this horizontal asymptote, which is 0. Did you get the same answers as this? Good. Perfect. Now let's move on to the next one right here. So first we have to determine, again, it doesn't matter which one you would want to determine first. Let's have the horizontal asymptote for this. So the horizontal asymptote would be this value right here. This is the horizontal asymptote. Remember, we're supposed to keep the sign of that one. So the horizontal asymptote then is y is equal to positive 3. And the vertical asymptote for this would be this value right here. Again, we remember that we're supposed to keep the sign of this and we switch the sign of this. So that's the trick. So that means our vertical asymptote would be, that's going to be x is equal to, that's a negative, so switch it, that's going to be a positive 1. So then we can go ahead and graph this two asymptotes. First, we start with the vertical asymptote. X is equal to 1, so it's going to be right here. So we can draw a broken line on x is equal to 1. That's the vertical asymptote. And the horizontal asymptote is y equals 3. So that should be up here. So we can draw a broken line over here. And then we are now ready to sketch the graph. Remember that this reciprocal function is approaching the asymptote but will never touch it. So it approaches the asymptote but will never touch it. It just gets closer and closer to it. So then we are ready to determine the domain. I gave you the trick on how to determine the domain. So it's going to be all real numbers except, that's going to be for the domain except for the vertical asymptote. So that's going to be except 1. And then the range would be all real numbers except, that's gonna be the horizontal asymptote, which is 3. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!